So today we are going to talk about the estimation of aniline solution by bromate-bromide. First, understand the theory behind this. Uh, Before I go to the actual procedure, let me take you back to something which you have already learned. You know that aniline or phenol are activated molecules because of the easy donation of the lone pair of electron on the amino group or on the oxygen. The ring is highly activated for the electrophilic substitution reaction. That means if I subject it to a electrophilic substitution reaction, both aniline and phenol, they undergo a polysubstitution. For example, aniline, when you subject it to bromination in water or in acetic acid, will form 2,4,6 tribromoaniline. Similarly, phenol on bromination in polar solvents will also form 2,4,6 tribromophenol. Now, you also know that the presence of polar solvents like water or acetic acid, it helps in the generation of the electrophile and it helps in the progressing of the electrophilic substitution reaction. Electrophile being generated, which is required for the uh, ring substitution reaction to take place. Okay, having understood that, uh, the second thing is what is the source of bromination that you can use for an estimation reaction? Can you use liquid bromine, which is commercially available? The answer is no, because bromine is highly volatile. Okay, because of its volatility, it keeps escaping. So, accurate measurements with liquid bromine are slightly difficult. So, the source of bromine actually is a mixture of bromate, potassium bromate, and potassium bromide in the acidic medium. Okay. The potassium bromate, being an oxidizing agent in the acidic medium, oxidizes bromide ion to bromine. Okay. And this bromine, which is liberated in C2, can now be, used for bromination of aniline. Okay, so let us see what will be that reaction. Reaction also you know already. Important thing here to note is that 1 mole of aniline here will require 6 gram equivalents of. That is the important thing to remember from this. Having said this, our aim is to estimate aniline. So how are we actually estimating aniline? The estimation of aniline is actually twofold. First of all, if you know the total amount of bromine which is liberated by a given volume of potassium bromate, potassium bromide, let us say that is VML. Okay. So you start with excess of bromine here. Okay. React it with aniline. Some amount of bromine will be remaining. The amount of remaining bromine is estimated volumetrically by using an iodimetry titration. Titration with sodium thiosulfate. If you know the total amount of bromine in solution, and if you know the amount of bromine which is remaining after reacting with aniline, the difference of the two will give you the amount of bromine which has reacted. Okay, that will be equivalent to the amount of aniline in solution. So that is the basis of estimation of aniline volumetrically by using the bromate-bromide method. Okay, so now let us understand the procedure for this reaction. The procedure involves 2 steps. The first step is standardization of sodium thiosulfate solution. How is that done? That is done by redox titration. We are using potassium dichromate, acidified potassium dichromate as the oxidizing agent. You could also use acidified copper sulfate as an oxidizing agent, but copper sulfate is slightly poisonous, so we have avoided using copper sulfate. So how is the standardization of sodium thiosulfate done? What you do is you prepare N by 10, approximately N by 10 sodium thiosulfate, okay, and standardize it by titrating with N by 10 potassium dichromate solution. How is the titration done? Please understand. What you will do is you will take a clean burette. Okay. Rinse it first with sodium thiosulfate solution. Okay. And then fill it with the sodium thiosulfate solution. Then you will take 3 conical flasks, the 3 titration flasks, and in each of them you will put 10 ml of potassium dichromate solution, 10 ml of 0.1 normal sulfuric acid, and 10 ml of 5% potassium iodide solution. You will cover the titration flask and leave it undisturbed for 10 minutes. This is to allow the redox reaction to take place. Allow potassium dichromate to oxidize potassium iodide to iodine. The reaction here will be you can balance the equation as yourself. I am only giving you the reactants and what are the products which are formed. So potassium iodide will be oxidized to iodine, and potassium dichromate will be reduced to bromic sulfate. That is the redox reaction. So this iodine which is liberated can now be used for titration with sodium thiosulfate. So what you did is that after 10 minutes are over, you will start adding sodium thiosulfate solution from the burette until the color of the solution becomes pale yellow. Okay. Then you will add starch as the indicator, which will change the color to blue-black. That is because of adsorption of iodine on the surface of starch. You continue addition of sodium thiosulfate until the solution changes to blue, which will be the end point. Okay. You repeat this titration to obtain 3 concordant values. The volume of sodium thiosulfate used in the titration. Then you draw a table, okay, and label that as standardization of sodium thiosulfate solution. Serial number, volume of potassium dichromate, which is pipetted out in ml, volume of sodium thiosulfate, again in ml. This will be the initial reading, and this will be the final reading. So, total volume of sodium thiosulfate used in ml. Okay. Perform this experiment to get 3 concordant values and let V1 be the volume of the concordant value of sodium thiosulfate. Then you can use the formula N1V1 is N2V2, where N2 is the normality of your standard dichromate solution, 0.1 normal, which you have prepared. The volume of dichromate you have used is 10 ml. So N1 will be N2V2 by V1. This is your titer value. So determine the normality of sodium thiosulfate. This will be the first part of your experiment. Next. In the second part of the experiment, you have to titration of aniline with the standardized sodium thiosulfate solution. What you do is you will take 3 iodine flasks. 2 of them you label as sample 1, sample 2. The third one you label as blank. Okay. In the sample, to a sample iodine flask, you have to add 4 things: aniline, bromate-bromide, distilled water for dilution, and then conc HCl. You have to add 10 ml of aniline, 10 ml of bromate-bromide, 10 ml of distilled water, and 2 ml of HCl, and immediately stopper the iodine flask. You have to do this for both the samples. In the blank, you will not add any aniline. 10 ml of bromate-bromide, 20 ml of distilled water to make up the total volume, 30 ml. And 2 ml of HCl, and this flask is also stopper. Keep all the 3 flasks in a truck, water truck, okay, is filled with water. That all of them are maintained at same temperature. In this, you keep all the 3 trucks. Okay, they have been stoppered, and you keep shaking them from time to time. Allow them to stand here for about 30 minutes. After 30 minutes, one by one, you will remove the stopper and put 10 ml of 5% potassium iodide. So that is added to convert the unreacted bromine. Okay? And allow the flask to remain in the water bath again for another 10 minutes. Please do not forget to shake the solution after you have added it. Again, you will have 3 iodine flasks, 2 sample, and 1. Now, after 10 minutes, remove the stopper, wash it with water, and allow the washing to run down into the iodine flask. Okay. After that, you fill your burette with sodium thiosulfate solution. Again, start with sample 1. Start adding sodium thiosulfate. Again, till the solution is pale yellow in color. Okay. Add 5 to 6 drops of starch. Amount of starch should remain same in all the titrations. Okay. Immediately you will get that blue-black color. Shake and then continue addition of sodium thiosulfate until you get a colorless solution. That is your end point. Okay. Now note this volume as Vx. Repeat the same with second sample and note that volume as Vy. Okay. Take the average of Vx and Vy, and that will be the volume of bromine which has remained after reaction with aniline. Now you repeat the same procedure of titration with your blank. The volume that you get here is V, that is the total amount of bromine which is generated when you have added 10 ml of bromate-bromide in water with HCl. Okay. So V minus V1 ml will be the amount of bromine which has reacted with aniline, which will be equal to, as I said, the amount of aniline in solution. Now, how are you going to use this to estimate aniline in solution? That we will try and understand. You will make table 2. Serial number, the volume of the reactants, volume of sodium thiosulfate used, and the total volume. This is sample 1. Please write whatever you have added here. This is sample 2. Please write whatever you have added here. And this is blank. Please write whatever you added here. Volume of sodium thiosulfate. You have to take the burette reading, initial reading, final reading. This will be the total volume of sodium thiosulfate. Okay. So this will be Vx, this will be Vy, and this will be V. The average of the two will give us V1. Now, please understand how we are going to do the calculation and how we are going to determine how much of aniline is there in solution. Now, 1000 ml of one normal sodium thiosulfate solution is equal to 1 gram equivalent of iodine. Please check the equation that I gave you is also equal to 1 gram equivalent of bromine, and which I told you is equivalent to 1/6 moles of aniline. Okay, so what we have is V1 ml of N normal sodium thiosulfate. So from this equation, it will be equal to 1/6 into V minus V1 into N into M grams of aniline, where M is the molar mass of aniline, divided by, this will have this term. Okay, so this will be equal to W. What is W? V minus V1 into N into M by 6,000 grams of aniline. That is the amount of aniline in the 10 ml solution that you printed out. So what will be the strength? In grams per liter. So the strength of given solution of aniline will be W into 100 G by N. You multiply this value by 100, you will get the strength of aniline in grams per liter. You could also calculate the percentage purity of the given aniline solution, how pure your sample of. If you divide this W by M and multiply by 100, what is M? M is the actual amount of aniline that you dissolved in 10 ml. How will you calculate this M? You will calculate this M from the amount of aniline you have dissolved per liter divided by 100. That will give you the amount of aniline which is actually dissolved in 10 ml. So ratio of this into 100 will give you the percentage purity of the aniline. That is the theory and the calculation of the experiment. There are few things that you have to be very, very careful about. Number one, never pipette aniline. We are going to put aniline in the burette, so you can take aniline from the burette. We will also put the bromate-bromide solution also in the burette. We take the bromate-bromide solution also from the burette. Okay. The amount of starch that you add for every titration should be nearly same. Okay. Always keep shaking your flask when the titration is being performed, because we are talking of redox titration. And always add starch towards the end. This is because, the starch uh, is reacting with the iodine, you know, to give you that blue black complex. Okay. Now, if you add starch in the beginning, the concentration of iodine is very, very high. A lot of iodine will get absorbed on the surface, and this will lead to error in your. That is why starch is always added uh, towards the end. I hope the procedure is very clear to you. You understand how the experiment has to be done. Now you can perform the experiment and record your result and show me the result.